This week, learn what a queue is and how you can use it. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, we're going to talk about a queue and use it to lead into next week applying queues with multiprocessing. So a queue is commonly used in what's called a producer-consumer architecture, where you have something that's producing tasks or data, and they get put into a queue to later be pulled out of the queue and used by a consumer. These two processes can run at slightly different rates, or it can just be something like you've got many things that are creating some output to be put into a queue to later be written to a file. This could also be sensors that are sensing the atmosphere and shoving that data into a queue so that when the processor has time, it can write it to a file. So as this diagram from a JavaScript tutorial shows, it can be this simple structure. It can also be a little bit more complicated, though, with multiple producers and multiple consumers putting things into and pulling things out of the queue. This is a little bit less traditional architecture. What I want to do this week was show you some of the basic functionalities of a queue in a non-multiprocessing or multi-threaded way. And so we can get to understand it, and then next week we'll use it with multiprocessing to deal with what to do when we've got many processes that are, say, processing some data and creating an output variable or output data set. How can we have all of those feed into one file at the end? We can't just have an open file and have all of them write because we don't know when those different processes are going to be writing to file. So over here in our Jupyter notebook, the first thing I'm going to do is an import. So from queue, import queue. Now notice the lowercase q is the module, which is a built-in, so you don't have to install anything. This is with Python since sometime in Python 2. And the uppercase q is the queue class or object from the queue module. All right, so we're going to create an instance of this. I'm going to call it queue for the variable name. And if we look at the docstring, we need to give a max size. Or, well, we should. If you don't specify, the queue can be infinite sized. That can be a dangerous thing if you have a runaway process that starts filling up your queue, but it can't ever fill up, so you eventually run out of RAM. So I always like specifying a max size. Now you should be generous with this because it's just the number of elements that can be in a queue. This is a first in, first out queue. We'll look at a little bit about what that means. But I would say if you've got an expected queue volume of, say, 100 items, maybe go ahead and double that unless these are very, very huge things, though it's not reserving any memory space like it would in C or C++. So I'm going to set max size in this case to be 3. We can look at, is the queue full, by calling queue.full, and it's not. We can say, is it empty, with queue.empty, and it is. We haven't put anything in it right now. So I'm going to put something in it. I'm going to put A and B into the queue using the put command. So now I'm going to ask the same questions. Is the queue empty? It's not. Now, is the queue full? No, it is not. So let's put something else in it. Let's put C in it. Now if I check queue.full, we see that the queue is full. So you say, well, what happens if I try to put something in a queue that's full? Well, let's see. Well, it's still waiting. You see that this cell has not run. So it's waiting for some other process to take an item out of the queue, and then this would get inserted. But effectively, it has hung up our kernel right now. So I'm going to go ahead and delete that cell, restart my kernel and run all cells down to my current spot. So we can use something that's q.put no wait. In this case, it tells us that the queue is full. So no wait means don't wait for there to be a spot available or something in the queue, just try to put it in. But in this case, it's full, so we don't get to do that. Now, how do we get things out of the queue? We call queue.get. So the first thing we get out is A. And that's the first thing we put into the queue. Way up here was A. So this is a FIFO, or first in, first out queue, as opposed to a LIFO, or last in, first out queue. Each would have a different use, but FIFO, I would say, is by far the most common. Now, we can keep calling queue.get, and we get B, and we get C. Let's call queue.get again. And we see we find ourselves in the exact same situation. It is waiting on there to be something in the queue to get. But in this case, that's not going to happen. So our computer will just sit there and spin. So I'm going to restart my kernel again. Just as there is a put no wait, there is a get no wait. In this case, it says there's nothing to get. The queue is empty. Now, if I put a queue.put, then we see it behaves just like get. So what can you put in a queue? Well, pretty much anything. Remember in Python that everything is fundamentally an object of some sort. So we could put dictionaries, we could put classes, we could put lists, arrays, whatever we want in here. One of the most common uses, I would say, for queues in Python are when you have multiple processes doing calculation and you want to write all of those results to a file. And I think you can see where this is going. All of those multiple processes will take their result and put it in the queue, while another process that is just responsible for writing to the file, so only one process has the file open, is getting things out of the queue. And we make that queue large enough that the writer is always going to be able to keep it somewhat empty before the reader puts more things in. Okay, one more thing that I want to show you. So I'm going to put a couple of things in the queue here. And a really useful structure is using a while loop when you're dealing with queues. So you can say something like while not queue.empty, print queue.get. So this structure just says we're going to keep looping over queue.get until the queue is empty, and then we're done. This is a nice way to go ahead and finish cleaning out a queue. So next Monday, what we're going to do is take what we've learned about multiprocessing in the past. We're going to work on some data, get an intermediate result, shove that result into a queue, and have that other writer process dealing with our file I/O. Now remember, with multiprocessing, we'll be working in a script instead of here in the notebooks. So if you don't have an editor installed on your machine, go ahead and grab one. There are lots of free ones out there. Atom is good. VS Code is very good as well, and it's the one that I generally prefer. I hope that you found this useful, and I'll see you on next week's MetPy Monday.